Another thing to focus on in this developmental psych chapter is the research methods that we use. So you might have seen some of these if you took a general psychology course, but let's talk about some of the specific ones that are really relevant to developmental psychology, but give a brief description of a bunch of others. So one way we do research is observation. Observation can be as simple as just observing someone in a natural setting. So if you want to learn about children sharing behavior, maybe you go to a playground and observe their sharing. Obviously, you should get permission to go to this playground to do that. But essentially, naturalistic observation is that. It's when you are trying to observe things in the real world, in their natural setting. If you wanted to look at how college students interact with each other, maybe you go to a coffee shop or something like that near campus. A laboratory setting is another good way to do observations. The problem with laboratory settings is you might change people's behaviors subtly, or even dramatically. People in a laboratory setting will know that they are being observed. They're probably there with informed consent to do the study, so they probably know they're part of a study. With that being said, you can elicit specific types of behaviors more easily, put them in specific scenarios. So it's a good way to observe if you want to pull out something specific. Another way that we do research is surveys. A lot of my research in my dissertation was on how to make good survey tools. Surveys are a way we can ask people about their beliefs, their ideas, what's important to them, what the behaviors or what the behaviors they're doing are, how they understand things. So you can get a lot of good data from surveys. There's also ways to make sure that you're getting really good, accurate data through systematically making a survey better. One thing that we have are things like lie scales. A really funny example of a lie scale is when you're asking adolescents about their drug use habits. One thing that we often do is put in fake drugs to the list of drugs. So if you're asking people, how often do you use these drugs? You might have someone saying, I use all the drugs all the time. But if you also include, let's say, three drugs that don't actually exist, and they are also saying that they use those all the time, you can be pretty sure that that participant is lying. So there's a lot of ways to make surveys better. There are limitations of surveys. Obviously, people can lie. You can't observe directly their behavior. They might be reporting behavior that is deflated or inflated over reality. But there's ways that we can make them better and use them as a good tool. It's also really easy to do statistical analysis with survey results. So there's a lot of good reasons to use them. Another good tool is interviews. Interviews take a lot longer than surveys generally, where you're asking someone things one-on-one. You can do group interviews as well, but it does take a long time. And with that, though, you can get a lot of really in-depth data that can be really informative and really useful. A standardized test is similar to a survey in specific ways. Oftentimes, you're answering questions or solving problems. The Stanford-Binet IQ test, a lot of IQ tests are standardized, where you can compare scores to other people. Where if you are comparing the score on a general survey from years ago to people now, if it wasn't standardized or did specific methods with it, you can't actually compare their scores to one another. Versus standardized tests, you can. A case study is a really in-depth observation of some unusual case, something different or unusual. It can be really small, like one individual, or it can be a bigger group overall. So one example is maybe this young child here is very, very intelligent. They can solve problems really well. Maybe they can already play the piano like a master. And so you're wondering, well, why? What are some other interesting things about this unique person who is masterful at playing the piano? So you have them solve problems. You study them individually for this special unique case and examining that. Another example here is these kids in Thailand, they actually made a club just in their playing, like without any kind of parental interaction, without being told to do this. They basically just started a club for fun with kids in their neighborhood. And over time, it became more and more structured into what we would basically consider a nonprofit. You can see this building here that they're in. They built that. They just used the supplies that were available, just to build this building. They use it to hold meetings, make plans of things like games that they'll play, tournaments that they'll set up, but also like community actions. So, like direct actions in the community, like let's clean up trash. And again, there's no parent involvement here. This is just what these kids and adolescents decided to do. So, it's a really interesting case that we can look at in a case study of what are the capacities of children and adolescents. And it seems like they're capable of a lot more than a lot of people give them credit for. So, a really unique kind of situation that occurred. That they essentially have what amounts to bylaws, like ways that they work together, just like a nonprofit would, which is very interesting. Oftentimes, we use physiological measures as well. And with that, we often use it in combination with other things. Like you could do surveys and interviews, you could do surveys and physiological measures. Physiological measures are kind of anything physical. So your fMRI, looking at other brain scans, heart rate, hormone levels. So I had some peers that were doing a study where they sent people short surveys, just like to their phone. Essentially, they would get a notification, they would answer like two questions, maybe three questions, take less than 2 minutes to do that. And then they would get that either like once to three times a day. And so they were doing this for a couple weeks, but twice a week, they would also do a cheek swab. And it gave them some hormone levels that they were looking for. That basically the participant would do this cheek swab, same time of day, and twice a week, put it in the mail, send it off to a lab. And that together gave them a lot of really great data on stress levels and happiness, things like that. And these measures are being used a lot more recently. You can pause the video and kind of consider why that might be. So hopefully you did pause and try to think of some ideas. But some of the main reasons that physiological measures are being used more now is because a lot of them are getting more accessible. It's getting easier and cheaper to get a lab to test blood samples or skin samples, to test heart rate, to get access to MRIs. So it's still not accessible as maybe we'd like. Fitness trackers and things can be useful, but maybe aren't always the best data. You might have seen that if you have something like a Fitbit. Sometimes it's just not getting it perfectly. But it is a really useful tool, especially in conjunction with other things. A lot of these tools have a lot of research behind them, so they can be very valid and useful. Other ways that we do research is descriptive research. We might just want to describe what we see. So surveys, interviews, case studies, we might just be describing this is what we're seeing. We can do correlations. We can compare variables to one another. Basically, a correlation is taking two variables and putting math to it. So we might look at sharing behaviors and if the kid ate all their lunch, like the percentage of lunch that the kid ate. Maybe there is a relationship there. We can look for a correlation. So correlations go from -1, which is the strongest possible correlation in a negative direction, to 0, which is the weakest correlation possible, no relationship at all, to +1. So +1 is the strongest possible correlation on the positive end. And this is a graph of a very strong positive correlation. Positive just means the arrow goes up. Negative just means the arrow goes down. So it's just math terms. This is a negative correlation. This is a positive correlation, but -1 and +1 are equally strong correlations. The positive and negative are just math. It's not a value of it being a good thing or a bad thing. So an interesting example is that we do find a strong positive correlation between ice cream sales and violent crime. So what does that mean? What does it mean that ice cream sales are correlated or related to violent crime? So, kind of nothing. Correlation does not mean causation. Ice cream sales are not causing violent crime. Violent crime is not causing more ice cream to be sold. There is actually a third variable here of heat. When it's hotter outside, we tend to see more violent crime. When it's hotter outside, we tend to see more people buying ice cream. And so while we can actually measure a correlation, a relationship there, it doesn't mean that one causes the other. They are related to one another. We can see a mathematical relationship, but it doesn't mean that one causes the other. Sometimes there's a third causing both two things in a correlation. Sometimes a correlation points to an actual causal relationship, but correlation just tells us we can see a relationship between these variables. So here are some actual graphs from some of my data, and this actually came from my dissertation. So I was working on this heroism scale. So it was 8 questions total, and this was 4 of its questions. So heroism is all of the questions, social heroism is 4 of the questions. So these were very correlated because these 4 questions were half of these questions. So you can see the graph here, very strong positive correlation. The number is 0.89. So very, very strong positive correlation because it's half the questions. Of course, it should be correlated. The questions in a survey should be pretty related to one another. But let's look at this heroism combined with something else. Let's look at it with purpose in life. So the graph over here, we can use this table, go along, and purpose is right here. So this is the graph. You can see it's pretty all over the place, but the calculator essentially can determine there is a positive correlation here. This is the number, 0.33. So there is a relatively weak, moderately strong, or I forget exactly the wording I use. It's not a super strong relationship, but it's there. There's a relationship between heroism and purpose in life. Some people with purpose in life also felt or also were willing to take heroic action. People who don't have purpose in life are less likely to take heroic action. But you can see there's some people that don't fall in there. This person's pretty high in purpose, pretty low in heroism. So heroism scores are going to be the up-down ones. Purpose scores are going to be the left-right ones here. So there is a relationship though, and the calculator can find that. So there are some examples of actual real correlations. One that was really good is social desirability. Didn't want the questions about will you do something heroic to give socially desirable answers for people to just want to make themselves look good. So I wanted a very low correlation. If you remember, 0 is the lowest correlation. 0.06 is the correlation between social desirability and heroism. So basically 0. There was no relationship between people answering socially desirably and their answers on heroism. So that was good. All right, another type of research that we do is experiments. Experiments can determine cause. We talked about correlations. Correlations just show us relationships. Experiments show us causes. In an experiment, you have to have at least 2 variables, like maybe sharing and food. There's 2 variables there. And then you have to manipulate at least one of them. You can't have more than 2, but you always have to manipulate at least one. You can have 3 variables, manipulate 2 of those 3, and all sorts of things. But let's keep it simple with a little example. We can have 2 variables here. We can have a variable of loudness of room and a test score. So we could put people in a quiet room, and then we could put another half of the class in a loud room, have them all take a test, let's say it's a math test, and see who does better. So these variables have names. An independent variable, or an IV, is the variable that the researcher changes or manipulates. So in this case, what did we change? What's different between these 2 groups? Well, the loudness of the room, right? So we've got a quiet room, we've got a loud room. The loudness of the room is the independent variable, the one that we as the researcher manipulated. The dependent variable is the one that's the final measured variable. It's the one we want to see if it changes based on the manipulation. So what are we looking at? What do we want to see if it changes? The test score. So the test score is called the dependent variable, or the DV. So we have an independent variable that we manipulate, the loudness of the room. We've got a dependent variable that we measure, the test score. And we want to see, is this group's test score on average higher than this group's test score? So you could do this in another way too. You could have a room that's totally quiet, and you could have a room with soft music playing, maybe some classical music. Maybe you'd have a hypothesis of which group would do better on a test. And you can actually do that experiment and see, well, does this quiet music cause them to do better on a test? So with that, there is another thing to be aware of in experiments. You want to make sure your groups are about as equal as possible. So there can be a variety of things that might affect math test score, right? What if uh, you just accidentally got everyone who's really good at math in the experimental group? So even though they're in the loud room, they might just be the ones that are better at math. And this is all the people who are not as good at math. Obviously, their score is probably going to be a little higher than the ones that are worse at math. So you want to split that up. You want to split the good math students and the bad math students between the groups. So let's say the orange are the good math students, the purple are the bad math students. They don't know their math quite as well. So you want to evenly or randomly assign them to those two groups to make it less likely that your result comes from that other factor. So we can do this with anything. Randomization helps for a lot of things because you might not know what could affect your experiment. Maybe it's how well they know math, but maybe it's how much they slept that day. If they remembered to take medicine that day, if they needed it. Maybe it's more dependent on the time of day. Maybe some people do better in the morning than at night on tests, right? So there could be a ton of other variables. So to reduce all of those possible confounds is what it's called, a confounding variable, you randomly assign them to two groups. So you've got the orange people and the purple people equally distributed. The orange and purple can be any of those variables. Maybe orange is they do better at tests in the morning. Purple is they do better at tests at night. Maybe orange is male, purple is female. Maybe it's orange is one ethnicity and purple is another ethnicity. Now, some of those would probably not have any impact on math, right? But depending on your experiment, it possibly would, right? Maybe a specific culture in a specific experiment you're doing might have more experience with what you're testing. So they might do better or worse based on the culture that they're in. So you want them randomly assigned to either group. So randomization really helps to reduce any other possible likelihood to make it more clear that it's your treatment, that it's your independent variable, that it's your manipulation that made the actual change. All right, another thing that we do is cross-sectional design. So this is the first example of a really developmental focused design. Again, development is change over time. Cross-sectional designs look and focus on change over time. So cross-sectional design is when you take people of different ages and you measure them at the same day or the same point in time. It might not actually be day, but just to make it simple, let's say I would go into schools today and I would get 5-year-olds, 10-year-olds, 15-year-olds. I would measure them all on, say, how well they could remember a random string of numbers. I count how many they could remember after 2 minutes of memorizing and then see who's got the best memory. So I can compare the 5-year-olds to the 10-year-olds to the 15-year-olds. Maybe I would see that the 15-year-olds remember more, 10-year-olds a little less, and the 5-year-olds the least. From that, I could make some conclusions. I could say, well, it might be that the 15-year-olds have better memories. So that is one way that we do developmental research is through a cross-sectional design. It's easy because we can get all the people at one time, even if it's not in one day, it's probably within like a week or a month of each other that you're measuring them in the same way. So with that being said, though, there might be differences, right? Maybe the 15-year-olds were taught in a different way than the 10-year-olds or the 5-year-olds. Maybe the way that they were taught in history was better. Maybe they got a better teaching method than the younger participants. So it might look like the older people are better at have better memories, but maybe they just have a better trained skill and it's not actually the age or the development. There could be history effects. Because of that, the best developmental method that we have is called the longitudinal study. And the key word here is long, because it takes a long time to do them. Essentially, what you do here is you take one group and follow them over a long time. So we'd take those 5-year-olds, we'd measure their memory today. We'd come back in 5 years, we'd measure their memory when they're 10, come back in 5 years and measure their memory at 15. And we would try to see what does the memory do over time. And since we're using the same group of people, they're having the same kind of history effects. So they're not going to have the weaknesses of the cross-sectional design. The weaknesses of this design is you have to wait that whole 10 years from the time they're 5 to 15 to get the rest of your data. And so that's a struggle. So another thing that you can do is put them together with a sequential method. In the sequential method, you would take 5 and 10-year-olds today, and then in 5 years, you measure the 5-year-olds who are now 10, the 10-year-olds are now 15. So you have a group that's 5, 10, and 15 compare. So you've got cross-sectional plus longitudinal together. So the really great thing about longitudinal is it gives us really fantastic data on development over time. We did some cross-sectional studies of cognitive capacities of adults. And from those studies, it seemed to us that after like the 40s and 50s, cognitive capacities were declining. And that's what people assumed for a long time because that's what the data we had said. But we got that data from cross-sectional studies comparing today you'd compare 80-year-olds, 70-year-olds, 60-year-olds, 50-year-olds, 40-year-olds, so on and so forth, all the way down the line through adulthood in a cross-sectional design. But then some researchers had enough funding over time that they could do the same thing with a longitudinal sample. So this had hundreds of participants. They measured inductive reasoning, spatial orientation, perceptual speed, numeric ability, verbal memory, a bunch of cognitive capacities, and they followed them from the time that they were 25 to basically when they passed away. So on this graph, we've got 88, but they did continue to follow them. And what you should see here is a general trend line where it's very, very flat, and then it really starts dropping off after about 75. And that's what we found with this study and other replications of it, is that even though you can see a drop here from about, say, 50 to a little above 45, you can see the scale is kind of cut. So this drop from 50 to 45, we can measure that, but an outside person and the person themselves wouldn't really notice that decline. So if you're their partner, if you're their friend, if you're their child, you're not going to notice this decline because it's not actually a very dramatic decline. So in reality, we don't see significant declines in cognitive capacity until people are pushing through the mid 70s. So that is a really inspiring thing, I think, as well. Another cool thing we found from these types of studies are that people who start to do cognitive training activities, whether it's learning new skills, whether it's actual cognitive training games, reading new types of books, engaging their mind, their line doesn't decline. It stays level or it even goes up. So old humans can learn new tricks. So we can keep our cognitive capacities increasing until we die, which I think is fantastic because that's one thing, aside from having like a neurodegenerative illness. If you're using your brain, the plasticity will allow it to keep gaining capacities unless you do have something like a neurodegenerative illness. That is another possibility, a big risk factor there. But yeah, this is longitudinal designs. It's kind of the gold standard in developmental research because it shows us very clearly how people change over time. All right, with that, this is a good video to watch to get a lot of detail on conducting ethical research. Your book goes over quite a few things that we'll skip, but I do want to make a couple emphases. One is that since the Belmont report really came out and showed that both medicine and psychology were failing participants in a lot of ways and being really terrible to a lot of participants, we've created review boards to try and help keep participants safe. So institutional review boards are an organization that anytime I want to do a study, I have to send it to an IRB, to an institutional review board, and say, hey, this is how I plan to treat participants. These are the questions I'm going to ask them. This is the process that they're going to go through the study with. This is what I'm going to do with their data and their personal information. Does this look good? Or do I need to make changes? Usually they come back with saying, can you clarify this? Maybe you need to make a change. For example, one time I had forgot to write it in there. I was planning to keep the data on password protected hard drives that were encrypted, but I hadn't written it in there. So I had to resubmit again. And then they said, okay, yep, it looks like you're treating participant data well, you're treating participants well, you can do the study. So there are other organizations in other countries like the IRB. Some of them are even more strict than the ones here in the US. So if you're interested in any of those, there's a link in the slides down here that you can click on. So some of the main things that we're concerned with that we want to keep to protect participants is one, informed consent. We want participants to be informed of potential risks. We might not be able to tell them absolutely everything about the study, right? I've done this before in an experiment. I've said, hey, you're going to be doing an experiment. There will be a control group. There will be a treatment group. Both groups are going to get interactive activities that they do online. It will last over the course of a week, about 15 to 20 minutes a day. And at the end of it, you'll do a survey. Tell them some of the risks, anything it's not really any more risky than they would get in general daily social situations. So I told them flat out the possible risks, but I didn't tell them which group they would be in. So I informed them of all possible things that would make them go, okay, yeah, I don't want to take that much time, or I am willing to take that much time. I don't really want to do computer activities. So I gave them the information to make an informed decision. That's informed consent. So confidentiality is another important one. You want to keep the participants' data confidential. So you don't publish their data in a way that people can figure out who it is, especially with minor data. If I have reported that I worked with 3 schools in the Southern California area, which I did, it might be possible to figure out who a person is if I name one of the actual schools. If I say this was a person who was this ethnicity in this grade, even if I don't use their name, but you can narrow down what school it is, you might be like, well, that's one of like 3 people in that school. So it's probably one of those people. You want to make sure it's not identifiable in any way. No usernames are published, no emails, no people's names, no phone numbers, things like that. Also, the data that you collect, you want to make sure it's password protected, encrypted, even locked in a like locked file cabinet or something like that. Another thing is debriefing. So make sure after the study, participants leave with no bad feelings. They don't feel like they did after the Milgram study that they might have just hurt someone, right? You want to make sure it's even best if they take away some skill. So if you've taught them something new about themselves, if they've gained a new ability, that's a really great way to handle debriefings. But at the minimum, they need the contact information of the researcher. You got to make sure that they're okay afterwards. And the last one is deception. Basically, we don't use deception unless it's absolutely necessary. So, for example, my earlier example of telling them you're doing an experiment, there's a control and treatment group. I'm not leaving anything out, but I'm not telling them exactly which group they're going to be in. So that's about as much deception as you would ever want to use. There might be cases where you might have to use a little bit more. Those are going to be more heavily reviewed by the IRB to make sure that you are doing as much as possible to give the most informed consent that you can to these participants. And the main idea with all of these research methods is to answer questions and solve problems. I'm an applied psychologist, so I do applied work, try and work and solve problems. So my hope is that when we find socially significant problems and when we have socially significant problems, maybe it's poverty or homelessness, we can do research to solve the problem. We can see what's been done in the real world, what are current community practitioners doing. We can look at theory around the systems that affect homelessness or poverty. We can use research methods to test out new things. Once we test things out and find things that work or don't work, we can send that information to audiences, whether it's policymakers, whether it's other researchers, whether it's evaluators. And then we kind of go in this cycle of continuing to work on this problem over time, and hopefully we solve those problems. So that is the cycle of applied research that I think we can take with psychology. It's really useful in a lot of different arenas. So that is also the end of chapter 1 in lifespan development. So next week we will be into chapter 2.